Good afternoon, everyone. Thank you for coming over here to see the presentation about discovering the Airtech advantage. Something quick about myself. My name is Tomas Havadra. I work as a technical support engineer at Airtech Europe. So main responsibility is to provide the technical support, but also to participate on some of the R&D projects we have within the Airtech group. And something about Airtech, as we are known mainly from the composite industry, where we are developing and bringing new features on market related to composite consumables. We started roughly 51 years ago in Huntington Beach in California, and over the time we expanded to all our worldwide facilities. Basically how we ended up in the additive manufacturing is that we have experience with compounding because most of our vacuum bagging materials for composite are made out of nylons. So we have experience with compounding, we have experience with tooling, and with all that together we started working on compounds for tooling that would be printable 5, 6, 7 years ago roughly, and nowadays we are one of the biggest manufacturer of printed tools as well as materials for additively manufactured tools. I'll be talking about the Airtech advantage, what it means. So basically there are multiple points that I want to point out. One of them is the Airtech publication activity, as we are pretty active in this field. Part of the Airtech advantage is also that in-house large-scale additive manufacturing devices, as we have 3 large-scale printers. One of them is in Huntington, sorry, one of them is in Tennessee, one of them is in Luxembourg. And last year we also purchased the CEAD FlexBot, so totally we have 3 devices that we are using in that field. We are engaging with machine OEMs, that's also why I'm here, engaging with software developers. We have an excellent worldwide technical support, and we are supporting in sustainable journey. We do universities and research institution supports, and we develop materials every year. So we are known for launching new materials at Formnext every year. Mainly in the presentation I'll be talking about 4 points from the list. About the first one, which is our publication activity. The second one is how we support and how we participate on the sustainable journey in additive manufacturing. Then how we support research institutions and universities, and also what materials we are bringing over here this year. Basically, the publication activity is based, in this case, on the additively manufactured tools, where in 2022 and 2023 we were running the research on how many cycles you can use your additively manufactured tool and how many cycles it will survive in the autoclave. Basically, the results were pretty nice. So we decided the next year, following year 2023 and 2024, to design the same tool, but made out of recycled polyterimide. In our terminology, it's the I350CF, which is a PEI with carbon fibers. So we were comparing then the results of the virgin tool and the recycled tool, of the performance of these tools in the autoclave. The results are pretty good. You can search these papers via SAMP, which is the Society of Advanced Process Engineering. It should be available online. The other point, how we participate on the sustainability projects. One of them is visible at our booth, where we support and we collaborate with Brumos racing team. Every year, last 3 years, we make tools for them. Then they make parts out of these tools, and we take back the tool. The tool is polycarbonate. We take back the tool, we recycle the tool, and we provide the tool to them again in different shapes. So basically, more or less, we are closing the loop as we are recycling the polycarbonate for them and printing new tools with that material, providing to them, getting back the tool, and doing this over again. Another part of the Airtech advantage is that we do support the institutions, research institutions, and universities. We have dozens of tens and tens of projects, successful projects, together with student formula teams in Europe. However, I'll point out two other projects that were already and also in collaboration with someone with CEAD. One of them is the Impetus Sailing Team project, and then the Force Hydrogen Racing project, where the Force Hydrogen Racing, it's a team from Netherlands. Then they reach out to us if they can get some material, or first they reach out to us if they can get some tool. So we offered materials, then CEAD offered the printing services, and then CEAD successfully printed the tool out of our PETG for them, and we helped them with the tool preparation. We helped them also with the layup, and then we helped them a bit how to do the infusion. They were infusing with epoxy resin. They were infusing a dry carbon fibers. So they did an infusion. I think it turns out pretty nice. You can see this is how the tool looked like after the polishing process. This is the simple layup of the resin infusion. This is the semi-finished, not trimmed final part. The next slide, there is the car, how it looks like nowadays. I believe it's still up and running. This is the hydrogen tank that basically the cover was made by on the tool that was additively manufactured. Another project that I'll point out is collaboration with Impetus Sailing Team / Technical University in Munich. They also have installed a flexible machine over there. In this case, we provided them a couple hundreds of ABS with carbon fibers. They printed that in multiple pieces, in 4 pieces. Then they joined it together. They mechanically bonded these 4 pieces. Then they also chemically bonded, and then they applied a gel coat, and they polished the surface to have a nice result on their infused part. I think this is one of the best results on the surface I ever seen on the additively manufactured tool. Then they did a standard layup resin infusion. They were infusing with MMA, with methyl methacrylate resin, and if I recall, they were infusing the flax fibers. This is the boat nowadays. I think it's the picture is shot on the Bodanza, if I remember correctly. So as you can see, the Airtech has been covering mainly tooling materials from the PETGs to ABS, polycarbonate, PI, PSUs. We are known for releasing these materials every year, and we are known for collecting data, providing these data to customers. We are known for providing actually outstanding amount of technical support to our customers and help them with printing their tools. It doesn't have to be only in the composite field. We have tested the additively manufactured tools in sand casting field, for example, silicon casting, concrete casting, thermoforming, but of course in the composite industry, because this is the core business of Airtech. Some of the customers has been using Airtech materials for their non-tooling applications, as well as applications in architecture and design, art. For example, as you see on the screen, some furniture fabrication. So we decided, based on this demand and based on the pressure from the customer side, to expand the Airtech range of Deltram materials, and we developed 8 new resins for final parts for non-tooling applications. So we expanded our T100GF range. Now we have multiple colors. We have white, we have green, we have black, we have also its nature color. Then we have Deltram T100CF, which is PETG with carbon fibers. And we have two new high performance materials, which is Deltram PC237 and Deltram I357. These materials are developed for end use parts. because they have higher performance than their sister/brothers materials from the current range we have. Just a deeper overview about these materials, as I just described, just expanded T100 GF series, which are now available in multiple colors for low-cost part production. Deltram T100 CF, which is the new material. It's not based on the T100 GF. Obviously, we have carbon fibers there now. Deltram T110 Clear, which we were able to develop completely transparent copolyester, completely transparent PTG, and these two new high-performance materials. Here's just a quick overview how these materials look like. If you're interested in them, we have them, of course, on the booth. And it's also basically my last slide of this presentation. I have few more words to say. It's that it doesn't mean that we are stepping back from the tooling market. We are still developing materials for use in the tooling market. However, we want to have happy customers from all industries as well as non-tooling. So we have now basically 21 or 20 materials for large-scale additive manufacturing. Thank you for your attention.